All right, so the next thing we're going to look at in terms of compositions of functions is how to find the value of a composition of functions algebraically. Now, I've already went through a graphing solution, but obviously we're not given any graphs here, so we're going to use only the functions. So here's my first example here. We're given f of x and g of x, and what we want to do is find the value of f of g of 2. So just like in my graphing lesson, the first thing you want to evaluate is what's inside that function. What's inside the composition of functions is g of 2. So find that value first. And how you're going to do that is use its corresponding function. So when you evaluate g of 2, you're essentially finding out when x is equal to 2, what is the corresponding value. So in your g function, you're going to let x be equal to 2. So 3 times 2 minus 7, okay, this is going to be equal to 6 minus 7, which results in a value of -1. So that's the value of g of 2. But we don't want g of 2. We want f of g of 2. So you're going to take that g of 2 value, which is -1, and you're going to put it inside the f function. So f of -1. So instead of working with the g function, we're going to work with the f function. So wherever you see an x in the f function, you're going to put in a -1. So -5 times -1 squared plus -1 plus 1. Okay, so let's see what this calculates to. -5 times -1 squared is going to give me -5. Okay, and -1 plus 1, that actually results in a 0. So my final answer is going to be -5. So to conclude this question here, we have found that f of g of 2 is actually equal to -5. All right, so there's your answer. I'll circle that for you. So that's my first example. Let's take a look at another one here. Given our two functions f of x and g of x, we want to find the value of g of f of -3. So just like in the last example, you're going to evaluate what's inside the composition of functions first. And what's inside is f of -3. So wherever you see an x in your f function, you're going to replace it with a -3. So we have 9 times -3 squared minus 1. Okay? 9 times -3 squared gives you positive 9 minus 1. This is 81 minus 1, and so I have a final value of 80. Now that's the value of f of -3. But we don't want just f of -3. We want the function g of 80. Okay? So we're putting the 80 inside the g function now. And so we're working with this function right here. So wherever you see an x, you're going to replace it with an 80. So you have 80 squared plus 80. Okay, so 80 squared is going to give me 6,400, okay, plus 80. And once we add these two values together, we're going to get a value of 6,480. And that's going to be my final answer. So if I'm going to summarize all of this, g of f of -3 is equal to 6,480. And I'm going to circle that for you. Okay, so as much as you can, try to conclude it just like that. We're going to take a look at one more example here. Given f of x and g of x again, we want to find the value of f of g of 2. Okay, so once again, evaluate what's inside that composition of functions. What's inside is g of 2. So wherever you see an x in your g function, you're going to replace it with a 2. So 4 times 2 squared plus 2. Let's keep going with our evaluation here. We have 4 times 4 plus 6. This is 16 plus 6, which is going to give me a final value of 22. Now that's g of 2, but we want f of g of 2. So you're going to take that 22 and you're going to put it inside of the f function. So f of 22. All right. So if we take a look here, our f function is represented by that expression, the square root of x. So this is going to be the square root of 22. Okay, so that is the final answer. When you have a radical, you can actually leave it in this form. You can try to simplify, but you can't simplify the square root of 22. If the question asks, you will definitely express it as a decimal if they want it that way. But other than that, you would just leave it like that. To conclude my answer or my solution here, f of g of 2 is equal to the square root of 22. And that's it. So that concludes my lesson on evaluating a composition of functions.